Okay, so this forces we're looking at the turning effect. Okay, so turning forces. So if you apply a force to an object, it may rotate. So you could push an object straight, okay, so it'll travel off straight, or you could actually push the object onto its side like that and it would rotate as it went around. Okay, so the turning effect, so let's say we have a pivot and you push on this thing there, it will rotate around. Okay, so that is what we call the turning effect of a force, which is the moment. Don't need to write anything else except for these 3 points. Now when we do this experiment in class, you're going to hang a couple of things here, and you'll find that when you add washers to the other side, that the multiples of the other side will be the same as the left hand side. So in other words, we've got 2 washers at 2 distance. Okay, so that equals 4. Now any multiple of 4 on the other side will also work. You could have 1 washer at 1 plus 1 washer at 3. Okay, and that will equal 4. So that will also work. Or you could have 1 washer at 2, 1 washer at 1 plus 1 washer at 1. That will equal 4. So that will also work. Okay, so you can have different multiples as long as they all equal 4. So the turning effect, the force, rotating around, is dependent on the force and the distance from the pivot. So a better look in a second. So what's the formula? So moment is equal to F times D, FD, where that is force and that is distance from pivot. Okay, and what's this measured in? What's the moment measured in? Well, it's newtons times distance, so it's Newton meters. Not newtons per meter, it is Newton meters. So the distance is the perpendicular distance, so there's a straight line there, straight line there. It is that 90-degree distance between the pivot, so that is the pivot, and the force, which is the weight of Garfield. Now we implicitly already know how to create the strongest moment. When you're using a spanner, you don't apply your force with that small distance from the pivot. The larger the same force from the pivot, the greater the moment. Okay, so we have a pivot. We have an object of mass 5 kgs, and it's located at a distance of let's say 3 meters from the pivot. Okay, you notice we don't measure from the end, we measure from the pivot. So if we want to work out the moment, it equals force times distance. So what's the force? Well, it's the weight of the object is going to provide the force. Okay, so what's the weight? The weight is going to be 5 times 10. Remember, weight equals mass times gravity. So I'm putting that into there for the force. So 5 times 10 multiplied by the distance from the pivot is 3. Okay, so we've got 50 times 3 makes 150 Newton meters.